Sorry there. All right, so this is going to be day 2 of the review. Day 2 of the review. So if you guys have any questions as I'm going through it, please make sure to reach out to me or just put in the chat or unmute yourself so I can get anything you might have before you take the test today. So first problem here, it says, was the determinant? It is a 3 by 3. So we could do this by hand where we add our extra rows and we do our 2, 3, 3, and then we multiply our diagonals, and every diagonal going, oops, let's make that pretty. Every diagonal going this direction, we add together, and then our diagonals going this direction, we subtract. Most of you guys probably won't do that because you guys can go ahead and just put it in your calculator. So remember a 3 by 3, and it's just going to be 0, oops, got too fast, 2, 3, -1, 3, 5, 6, 3, and -2. And then I go down to my operations and I want the determinant of it. There we go. And it's just going to be my -7. So that was just put into the calculator. Easy peasy when you have that option, right? There was a few of you guys that had this as a question. So there's a couple different ways to go about this. I had sent out a way to do it, and I'm going to actually show a different way to do it. This isn't the full way. Oh, thanks for reminding me. Calculator's in the way. Okay, so what they want to know here is what is happening is this: a triangle is located on a 3-dimensional coordinate plane. So that's going to be coordinate plane that's 3-dimensional. 2-dimensionals are x and y. 3-dimensional will be our x, y, and z. So it's going, like we have our axis going left and right, up and down, and then you have your other one that's going through it. So you're getting that depth. So it'd be like kind of going through this way. So you have up and down, left and right, and then it'd be going through this way would be your z. So when we talk about this 3-dimensional triangle, it says that the matrix A shows each of the vertex, where the first column represents the x, the second column represents the y, and the third column represents the z. So this would be 1 triangle, 2 triangle, 3 triangle vertices. So it says the triangle is dilated by a scale factor of 2. So it's enlarged by a scale factor of 2, then translated, then moved by a factor of matrix B. So it's moved by this factor, resulting in the image as represented below. So this is what you're going to get. So when I do 2 times this A, so I enlarged it, and then I'm going to shift it over this amount B. When I do that, I end up with, this is my new vertice for this first one. This would be that second vertice, and this would be the third. So this is my A, my original, and then this is where it ends up. So for that second point, this is the original, and this is where it ends up. And for that third point, this is the original, and this is where it ends up. Whoa. Okay, so what is going on here? How do I go from here to here with this information? So I know what this A is. I'm looking for the B's that are going to make this happen. So one way to go about this is I could go ahead and I could do, if I'm solving for B, this is I'm gonna call this some C. So if I had 2A plus B is equal to C, so C is our solution there. If I want B, then I could just go ahead and do 2A from both sides, and B would equal my matrix C minus 2 times that value. Matrix C, so this matrix here, minus 2 times that value. So that's one way to do it. And that's perfectly acceptable. Actually, I think I'm going to go ahead and do that. I think it'll be easiest for you guys. So I need to figure out then what is, so if I'm looking for B, what is 2A? So my C is going to be 5, 2, 3, 9, 0, 1, 7, 6, -1, minus my 2A is going to be, so it's 2 times each one of these. 2, 4, 2, 6, 2, 0, 4, 8, -2. And when I do this, 5 minus 2, 2 minus 4, 3 minus 2, I'm going to get my matrix B. So it's going to be 5 minus 2 is 3. I'm going to get -2. I'm going to get a +1. I'm going to get 9 minus 6 is 3. -2, +1. And then I'm going to get 7 minus 4 is 3. I'm going to get -2 and +1. Notice that they're all the same, because when I make that shift, when I enlarge it by a factor of 2 and I make that shift, I'm doing the same thing to each of the equations, the same thing to each of these equations. And so when we talked about this is going to be my X. Remember, we already said this is my X, this was my Y, and this was my Z column. So this is telling me then that my X is going to be by a value of 3, my Y is by a value of -2, and my Z is going to be by a value of 1. So when I read these, 3 units in the X directions, that's the 3 units right there. So I already know it has to be one of these two, can't be either one of these. Then it's -2 units in the Y direction and 1 in the Z. And so that's where those values come from. Kind of tricky because we didn't do too much with those dilations, but it's the same kind of math that you guys have been doing. It's just kind of applying it a little bit more. The other thing that I was going to point out, the way that I had showed it, but I think seeing the big picture is better, is really you only needed to focus on one equation. So you could have just used this value, like focus on just this piece to get these values, but not seeing the whole picture kind of throws you guys off. So I figured it'd be best just to do the whole thing. Alrighty, my next one. Ready for me to flip? All right. So they tell me that this is my matrix R, and they say if 3, and this is times, and so I wanted to make sure this isn't a variable X. So it's saying 3 times my matrix here times R is found to perform a transformation. So this is the operation to move this matrix. It says, what are the coordinates of the transformed matrix? So what are these coordinates? So different than the last one on the way that they organized it, because we were looking down for my X, Y, and Z. In this case, this is your X and this is your Y. So going across, so each one of these, this is 1 coordinate, 2 coordinates, 3 coordinates, 4 coordinates. And so you're going to see what's going to happen with my transformation here. So I'm going to do 3 times my matrix times R. So that's telling me it's 3 times 0, 1, -1, 0 times 0, 0, 6, 6, 0, 6, 6, 0. So all I'm doing is performing this operation here. So take it piece by piece. First thing I'm going to do is I'm going to go ahead and I'm going to distribute the 3. I only do it to my first one. It doesn't go to each one. So I'm going to end up with then 0, 3, -3, 0. And then I still have my 0, 0, 6, 6, 0, 6, 6, 0. So I need to multiply these two. In order to multiply them, remember the dimensions. So this is a 2 by 2, and this is times this is going to be a 2 by 4. So I can multiply them as long as these inner dimensions are the same. They have to be the same. And they are. They're both a value of 2, which means I can go ahead and multiply. So when I multiply these, it's rows by columns. Rows by columns. All right, so let's go ahead and let's look at that first one. So it's 0 times 0 is just going to be 0 plus 3 times 0 is 0. Oh, this is making it easy with all these zeros. It's going to be 0 plus 3 times 6 is 18. It's going to be 0 times 6 is, of course, 0. And then it's going to be plus an 18 again. 0 times 6 and 3 times 0 is going to also be zeros. And then I go to my next row and I end up with -3 times 0 and 0 times 0 is again 0 plus 0. This is going to be a 0 plus a 0 again. Lots of zeros are making a lot of things 0. So it's -3 times 6 is a -18 plus 0. And this is going to give me another -18 plus 0. So when I clean it up, I end up with 0, 18, 18, 0, 0, 0, -18, -18. My answer is not a matrix, but this is my answer here. So how do I correlate it? Well, remember, each one of these is a coordinate. So 0, 0, 18, 0, 18, 0. This is 18 and my -18. And my last one was my 0, -18. So those are going to be your coordinates. And that was this option right here. So again, these are your X and your Y values. All right. My next one. Sometimes just reading through things or understand what are they asking, that's just really what throws you guys off, not quite understand what the question is saying because it's written in a weird way. So this is pretty basic, but I wanted to just kind of point it out because sometimes it throws you guys off. So it says if A, B, and C represent 3 matrices of the same size, because remember, if you're adding, they have to have the same dimensions. You cannot add unless they have the same dimensions. Different than multiplying. Multiplying, they don't have to have the same dimensions. Adding, they do. All right, so they have the same dimensions and A plus B plus C is equal to 0, then which of these statements is true? So what this basically tells me, whether it has parentheses here or not, it doesn't matter when it's addition. So this is just saying A plus B plus C is equal to 0. So if that's the case, these are talking about terms. So this is saying row 1, column 1, so that first spot in my matrix for each one of them. What happens when I add them up? Well, if I'm taking matrix A plus B plus C, then A11 plus B11 plus C11 would also have to equal 0. Each corresponding term equals 0. In other words, if they had an A32, I don't know how big the matrix is, but in general, if I had an A32 and I add it to my B32 to my C32 and I add each of those terms, because that's describing the same location and I can add those, then that has to be a value of 0. So that's all they're telling you. So when I look here, there's only one that equals 0. Some of you guys go, but wait, it doesn't, they have parentheses. Well, remember, addition, I could parentheses this, I could parentheses this, it doesn't change it. So it's this piece right here. And this last one, this was an add-on. I actually had several people email me about this one, asked if I could do this one today. And I think it's because of this variable and it just throws you off that it's here and here. Because when we talk about these, we use the idea that AX is equal to some B. Same process we've been doing. So if I want to get rid of this A so I can solve for X, then remember we would take the inverse. And what I do to one side, I do to the other. So that my A inverse times A cancels out. So X is equal to A inverse times B. Oops. And I think that's the part that throws you guys off, because when you look at your matrix A, if I say A is 4y01, and I want to find the determinant of this, because remember my inverse is 1 over the determinant, and then I switch my values. We'll talk about that in a second. But I need to find the determinant. I think this is the part that really throws you guys off. So when I look at the determinant, it's 4 times 1 minus, and I think because it has a variable in it, you guys are like, well, I don't know how to find the determinant. But really, it just cancels out. So it becomes 0 times y. So my determinant's really just going to be 4 because this is just a value of 0. So my inverse then is going to be 1/4. I switch my 4 and my 1. those switch locations. My 0 and my y take the opposite sign. 0 just stays 0. My y becomes a negative y. So my inverse is 1/4 negative 1/4 y, 0, and 1/4 times 4 is just going to be a value of 1. So I end up with x is equal to 1/4 negative 1/4 y, 0 and 1, and I'm going to multiply y and 4. Now at once row 1, column 1 spot, row 1, column 1 is really the only one that I care about. So I'm just going to only multiply. Well, we'll just go ahead and we'll do both. So I'm going to do my rows by columns. So my matrix X is equal to, it's negative 1/4 y, it's 1/4 y, 1/4 y, plus a negative 1/4 y times 4 for my first spot. My second one's going to be 0 times y plus 1 times 4. So x is equal to, this is going to be just a value of negative y, right? 1/4 y times 4 is going to be just a negative y. So I have 1/4 y minus y. That's just going to give me a negative 3/4 y. This becomes a 0 and 4. So if I want row 1, column 1, it's right here. So my answer should be negative 3/4 y as your answer choice. So this one, a lot of you guys struggled with. I had quite a few questions on that. Try not to overthink some of these. And I really think that maybe part of the biggest struggle was the variable here when you found the determinant and seeing that, but it didn't actually turn out to be too bad of a problem. If you come up with anything else today, send me a message. I'll work it out, send it back to you. Otherwise, best of luck on your test. Before I let you guys go, do I have other questions right now? All right. If we don't have any, then good luck on your test. And if you need anything, again, just reach out. Otherwise, I will see you guys tomorrow for the start of a new chapter. Take care.
Bye. Thank you.
You're welcome. Bye.